Hello 7th graders, welcome back to Mr. Kendrick's online math class. Today's lesson is lesson 2.1, part A of rational numbers. It is the first lesson in chapter 2. If you'll remember from chapter 1, we talked about integers, and we described integers as being positive or negative whole numbers. But what do we do if we have numbers like this? Like fractions, 1/3, -1/3, -2 1/6. Are they considered integers? No, they don't seem to fit the rule of being a positive or negative whole number. These fractions are part of a whole. Okay, so let's start by looking at rational numbers. The word rational comes from the word ratio. And remember, a ratio is a comparison of part to whole. So if we think of pizza and we had a fraction of 3/4, we could say that that is 3 pieces of pizza out of the 4 pieces of pizza. So a fraction is a ratio comparison. Okay, so if we look at a rational number, integers can be considered rational numbers because we can write any whole number as a fraction. And you can see up here we have 2 is equal to 2/1, or 2 out of 1. -3 is -3 out of 1. And we can see 0.25, or 25 hundredths is equal to 1/4. So rational numbers can be written as a over b, or in fraction notation, a over b, where a and b are integers. So that means they are positive or negative whole numbers. But we need to remember that this only works as long as b is not equal to 0, because b is in the denominator, and we can't have 3 pieces of pizza out of no pizzas. That doesn't work. What about decimals? If we have decimal numbers, where can those go? Do those fit the integer rules as whole numbers, positive or negative? No, they don't. But because you can divide any integer by any non-zero integer, you can use long division to write fractions and mixed numbers as decimals. So we can write a fraction as a decimal, like you see up here. We can write decimals as fractions, but we can also write fractions as decimals through division. And when we write a decimal number, there are 2 different types of decimal rational numbers. Okay, so we have a terminating decimal, which means that the decimal ends. So if you see over here, we got 1.5, so that means that that decimal ends at 0.5. There's no more decimal numbers after that. Or if we have 10.625, that's the ending of the decimal. There's no continuation after that. But we also have repeating decimals, which means that the decimal number will be completed or continue forever in our calculators. So if we continue to divide and divide and divide, the decimal would always continue to repeat. So if you look at the negative 1.333, and it would continue, that 3 would continue on forever. So the notation that we use is bar notation, and that means that that decimal is repeating. So if you can see in the second example here, the 0.151515 is repeating, so that would continue, that 15 would continue to repeat forever. So when we have a situation like that, the bar notation goes over both the 1 and the 5. Okay, so these fractions and decimals are considered rational numbers. So you'll notice here that the integer square is inside the rational number circle, because, like you see up here at the top, whole numbers, both negative and positive, can be written in fraction form. Okay, so as long as it is a whole number, positive or negative, that can be written in fraction form, it can be considered a rational number. Okay, and we can also write fractions as decimals as well as decimals as fractions. So integers as well as fractions and decimals are considered rational numbers.